Okay, good morning, welcome to
FamilyMath858.
FamilyMath858. Now, today we're going to be talking about the subject that will come up later in calculus. But since you're starting to look at lines in algebra, and this is something you'll be seeing later this year in calculus, that'd be fun to talk about it today. Kind of an interesting connection between the two. And so Euler's method is trying to figure out how to explain the problem to a non-calculus person. So if you know the slope at a point, then you can approximate it. Then you can approximate. Okay. If you know the slope of a point at a function, if you know the slope of a function at a point, then you can approximate that function. See an eraser anywhere? Thanks. So, you know, if I have a function that looks like this, and I know maybe I don't know what it looks like, but like somehow someone knows it looks like this. But I know I'm at this point here, let's pretend that's 3, 1. And I know the slope at that point, let's say the slope is 1.
Okay.
Do you know what that means? Do you know what the slope means for a line or for a function?
Whether how much it's going up or down?
Yeah, how much it's going up or down. You can even be a little bit more precise. Can you give me a little bit more precise on
I
the
guess
slope?
you know if a function's increasing or decreasing by approximately what amount?
Yeah, but what does the slope itself mean? What is the
I guess the
definition?
steepness. Steepness of the function?
The definition of slope.
Oh, the change in y value over the change in x value.
That's right. So the slope for a line is the change in y over the change in x. Have you ever seen me use deltas before for change?
No.
No? Okay, so this just says the change in y divided by the change in x nearby.
Okay.
So the other way you can think about it is how much it goes up or down divided by how much it goes across.
Okay.
Okay. So if the slope is 1 here, that means for every change in y, the change in x is the same as it.
Yep.
Or for every change in x, the change in y is the same as it. So if I go over 1 to 4, where would I expect the y value to be approximately for this function?
4, 2.
Okay, why?
Because you're going right one and then up one.
Okay, and why would I expect the going right 1 to mean going up 1?
Well, that's the slope is 1, so you've changed in. Yeah. So a change in this direction will result in a change in the y direction.
Very good, high five. Very nice. And what if I was at, let's say this point here. Let's pretend I didn't label these points before, because I'll label this the point 1, 2. And it looks like the slope here might be what?
That'd be maybe about -1.
Yeah, I'm going to call it -0.5 to make it a little more challenging. So I'm at the point 1, 2, and to make it even a little bit more challenging, I'm going to ask, where would we expect to be at the point 1.5, comma what? And I want you to tell me this.
Alright.
So I know I'm at the point 1, 2, and the slope is -0.5. So where do I expect to be roughly when I go over to the point 1.5?
So you know change in y over change in x is -1/2.
Yeah. Change in y over change in x is -1/2.
So in this case you know what the change in x is. Because you know that's 1/2.
Okay.
So change in y over 1/2 is -1/2. So y must be -1/4.
Okay, not y is -1/4.
Or to change in y is
Change in y is -1/4. Does this make sense?
Yeah.
Okay.
So the y value here at this point would be 1.75.
Very good. And it's not exact, as you can see from a little better from this one. The line doesn't approximate the function, doesn't make exactly equal the function. And just like over here, a little harder to see, but it doesn't exactly necessarily equal the function, but it tells you a good approximation.
Yep.
Okay, and we're going to talk about some situations where this might come up, because it seems weird, right, that you might know the slope, but you wouldn't know the function.
Yeah.
Yeah, like how could that happen? But I'm going to show you some situations where that happens.
All right.
All right?